cloud.google.com, right? The first thing that you need to have to run this workshop is a project, set it up. So you can pretty much create one here if you don't, right? But if you do, you can use the project that you use as default. I have a lot, but I use this AI research on the top to usually give workshops, right? Another thing that you can be aware of, go to billing, and then if you have more than one multiple billing accounts, you can go to the one that is linked to your project. But when you apply your credit, go to manage billing accounts and see in which billing account you have applied your credit, right? Because sometimes, let's open this one, which is the standard one for me, Pedro billing account. And if I go to credits, you see, oh, sorry, there is no $5 credit here. Why? Because GCP has created another billing account here, okay? So if I open another billing account, when you apply the credits, sometimes it creates a new billing account. You're gonna see the $5, okay? So when you change the project associated with this billing account, you go to your project, and then you can click here and change billing account, right? So that's how you can use the credits that Google has provided us. So first thing, starting the code lab, you're gonna see that in the first step of it is gonna show the same code that I've shown you guys on the slide. And it's gonna tell you the developer journey of being debugging code at late at night and how we're gonna solve it doing our code review assistant pipeline in general. So first of all, let's open, you can pretty much skip this. This is just a tutorial on how to redeem credits. And we're gonna now open our Cloud Shield section. So on top of console.cloud.google.com, you're gonna open this, and this is gonna initiate and start a new machine on cloud on Google. Sometimes it's gonna ask you to authorize the session, so it's gonna pop up an authorization model, and it's important to you to authorize that so we can have access to be here, right? So the first thing we're gonna do, we're gonna copy this and paste this. This is setting up on our session the project that we should use during our workshop, and you're gonna see updated property core project. If you wanna see which project is here, you can just give an echo and enter, and you can see that this project here is the same one that I have selected on the top, right? So make sure that you have the same project linked to the same billing account, so we will not spend your money or your credit card. So we can just do gcloud auth list to make sure that we have our authentication things enabled, and it is. This is a thing that we should also paste. Yes. You need to click here. There will be a code. Make sure to select the same Google account that you have on the console. Yeah, that's key. It's going to give us a code that we need to copy and paste on terminal back. Okay, so we should copy this code and then we're going to paste this here. Nice. So we're going to go back, and right now we're going to run this command. What is this doing? You can notice that I am not inside a virtual environment. Everyone knows what is a virtual environment on Python. You create a separate environment to run and install your packages. But right now we are not using it. We are installing this globally. We're going to install the Google ADK package so we can start using it. So sometimes it can take more time if you are using this on your corporative laptop, and if you have proxies on it, sometimes it's going to take a lot of time. And I think to make sure, if you are going to use ADK professionally on your company, make sure that all the dependencies are allowed inside of the company. Because sometimes ADK will not install if some of them are not allowed on your proxy, right? So after we install it, we can check ADK version, and it's gonna hopefully give us the version. ADK version 1.29, right? And then, Pedro, how can we start creating agents? Okay, we're gonna run this command. ADK create my first agent. ADK create space. You can name the folder that you're gonna be creating, that ADK is gonna be creating for you, right? So let's enter it. We can choose. We're gonna type 1 here, and then we're gonna type 2 here. You can type enter because you already have set up your project, so you can see AI research and then the number. You can press enter again. And let's do an ls. And we can see here that the folder has been created. And let's go inside of it. Let's see what is inside. So ADK has created for us an agent.py, an .env, and an init.py. Okay, this is the basic structure of ADK. We can do right now nano.env just to make sure that our project is correct. So you can see here on the second line that the project is the same that I have set it up before, so it's gonna work. And then I will open right now the agent.py, nano agent.py. Look here, we have like root underline agent and then defining an agent from Google LLM underline agent on the top. We are defining the model, the name, the description, and instruction. This is the basic thing that we need to set it up to make an agent running on ADK. We're gonna see further on our lesson today that we can a lot of properties that we can define here. For example, you can infer what is the final prompt that is being sent to the model itself. Because let's open the doors here. At the end of the day, what every agentic framework is doing is creating a better prompt to send to the provider, right? Because at the end of the day, all of your tools, all of your MCP tools, everything that you configure into your agent is converted in a sequence of strings and is concatenated on the prompt. And we send this to the LLM, okay? So the framework on the back parses the LLM output and runs the tools for us, do the transfer between agents, and do all the magic happens. But at the end of the day, we are just creating prompts in a better way, right? So we're gonna exit here. And we're gonna run our agent. But before, let's go one folder back, and we're gonna run ADK run and the name of the folder, which is the same name that we have been named before. Look here, there is some ways to run Google ADK, okay? We can run it through web, that we are gonna see later on the workshop, but you also can run this on the terminal. And you see, if I type hi, it should answer me, like, who has the original ceviche? Peru or Chile? Let's see. Hopefully, it's gonna answer both. Not correct. We should try some prompt engineering, right? So going back to our to the start of everything, let's see if this agentic structure that we have created is good on answering code questions, right? So I will ask, review this Python code, def add, receiving A and B as parameters, and let's see the answer. Do you think that this answer is good? It is, right? You don't think so? It's like a one-line function and look up all of those information. It is a good response for the first look. But nothing has happened here. There is no deterministic tools here. we don't test that function. We don't try to research on that function. So it is a do that first, but if we try to look deeper and raise the bar of our complexity on the code, we're gonna see that this is gonna fail. And this answer actually is not good. It's pretty bad, to be honest. So we can stop running our agent, doing Ctrl+C, right? And right now, we're gonna start our workshop, and we can remove our folder, or not. You can do if you want, you can not remove if you don't. But what we're gonna do is first create our repository. So we're gonna clone. Nice, do an ls. So we have here ADK Code Review Assistant. We're gonna enter this folder, okay? And then we're gonna change our branch. Nice. Very cool. Another thing that I want to show to you is that you can open, let me just see. Yeah, I am inside of our folder that we have cloned, and I can click here, Open Editor, and this is gonna open for me an instance of the VS Code forked by Google here. So we're gonna work with both terminal and VS Code, right? And it's gonna load all of my projects that I have on Google Cloud. So you can see my first agent, you can see this other workshop, and you can see this ADK Code Review Assistant, which is the one that we will work on today. So let's go back. And right now, we're going to create a new Python virtual environment. So I will go back and we'll create a new VM. This is going to help us to install the packets that we want in a containerized way. I don't know if this word exists, but that's what we are going to do. So if you do this, and then it should return you that you have the VM installed, right? Then we are going to activate it. If you are using our Cloud Shield, you don't need to worry about if it is Windows or Mac, it's going to be Linux. So we're going to activate it, and you can make sure that you have activated your virtual environment by checking here at the beginning of the terminal line that you have .venv or the name of the folder that you have been chosen. You don't need to name it .venv, you just need to name it .something that you can choose. Usually we use .venv, right? So right now we're gonna activate and install all of our requirements. This can take a little bit of time. If you have proxies, if you have DNS, different configurations on your machine. Usually we don't here because we are on cloud. And don't be worried because I will speed it up right now, but you can try it at home. The code lab is very detailed and you can follow all those steps later or right now if you want to do it. Okay? So let's wait. By the way, did you guys like it, the paçoquita, or not? No? Who don't like it? Oh, everybody likes it. Nice. These final steps still takes a lot of time. Google downloads a lot of libraries on the back because we have a lot of connections through Google ADK. You have a lot of self-defined tools that you can use inside of the package, so it downloads a lot of things on the back. So be aware that this can take some minutes. But this is a standard thing. ADK does this every time. Nice, so it has installed. Let me do something. Let me just check. Can you see? We don't have the .env. We just have the .env.example. So, but before, let's do this. Otherwise, we can't run it later. This is gonna allow me to run the project as module later. So we should do this python.e. Nice. So now we're gonna create our env file doing this cp command that is gonna copy the example into this brand new .env. Okay. we can see this running cat or nano, but we can also change to editor. Well, we will not be allowed to see here, so nano.env. And yeah, look, we don't have the correct project ID here, so we should replace with our project ID. Let me see if I can copy this here. Yeah. And let me paste it. And then we can write out. Yep. And save. So if we do again, nano.env and grab project. Oh, nano will not run. Sorry. Looks like it locked my terminal. Let me open another session. As I open a new thing, I will just run this again to make sure that I have the authentication, and then I will do this. Just make sure again. Sometimes if you face different errors when you run the sections, you should do this auth login again. Okay, we're gonna paste it. Nice. Let's see. CD ADK. No, yeah. This is CD. Let me close. Oh my god. Let me rf our .env. And let's do this copy process again, right? Nice. Yeah. Okay, let me paste my project ID again. Now we can write out. Sorry. We can write out. Yep, and then X. Nice. So we have already authenticated over here. We have our project ID that we have pasted. We have done this login, and now we should enable all the APIs that we are gonna need to run the project. So we should paste this command gcloud services enable, and this is going to enable all the APIs that we should do. And you can see here operation blah 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 finished successfully. This is the return that you should wait. But sometimes it can open an error, and it is because you don't have the billing account, right? So if you don't have a billing account, this is not gonna work. So make sure you have the billing account correctly. This is gcloud artifact repository that we are gonna create, because in the later today we are gonna deploy this to Google Cloud, and we should deploy in a container format. So we should have where to store it, and for this we are gonna create this artifact. This is gonna return an error for me, maybe because I already have. So if you don't have, it's gonna succeed for you, right? After that, we are gonna set a lot of the IAM permissions that we will need. So we are gonna create a new variable here, and then we're gonna use this new variable through these commands over here. You can press enter. This is gonna allow the account to access the resources that we want on GCP. Nice. So right now we're gonna really start building our first agent. So the first agent that we're gonna do is gonna change. Let me zoom in. We have on the beginning of our talk that simple LLM agent that we have cloned from ADK, right? So what it was, just a simple agent without a better prompt that we just place the code and get an output. right now we're gonna try to make this more deterministic by adding some tools, right? So we are gonna add some tools that is gonna analyze our code structure, doing this by AST, which is a programming approach to understand the code, the functions, the methods, and how these things has relationship. And then we're gonna store on state. But before, I wanna share a little bit about states, right? Let's suppose you create an agent and you create a tool. And on that tool, you create a new parameter, call it code as a string. And then you type on your prompt like, whenever the user sends you a code, please call the code tool, right? And the code is a parameter. Sometimes, or let me ask a question, can you be 100% confident that the LLM is gonna pass through the tool exactly the same code that you have inputted for the LLM? No, we can't. Sometimes it will not. So we need to have a way to pass information through agents, through tools, through callback functions, for example, in a way that we don't rely on the LLM to do it. So we need a way to program that, to code that. And this is states on ADK. So we can open and create new variables and put whatever we want on those variables, and we can access the value of the states inside of our tools, agents, callback functions, and whatever we need, right? So that's what we're gonna use today. And sometimes, for example, in this tool code that I have explained right now, we can, before starting our agent, creating a session, and in the session, we pass the value for the state, right? So if you have a pipeline, this is not the case, but if you have a pipeline on your company, before calling the pipeline, you create the state with the values that you need. So you don't need to pass to the LLM. In this way, LLM has access to the variables. So let's go back. We're gonna open this tools.py on our editor. So let's go back here, open editor, open our folder. So be aware that ADK needs you to create a different folder inside of the main one so you can run all of the things. And let's open the tools.py. The way that we have built this collab is very interactive and educational. So you can just look here, module 4, step 2, and you're gonna copy this and you're gonna paste this, right? So what is this doing right now? Look here, to underline context. What is this? Let's see here. This is a parameter, to underline context. But I just said that LLM will not send anything through the parameters. Yeah, the LLM will not, but ADK will. So when the LLM returns a response on the back from the prompt asking to run that tool, ADK is gonna intercept that and put the context as a variable on the tool, right? So this way, this is our dictionary of context. So this is where we can access the values from the pipeline regarding our state. So if you look here on the import, it's from google.adk.tools, import tool context. Sometimes you're gonna import from different places inside of google.adk, but it refers to the same thing, okay? To the same state. So we are defining this code analysis and how much lines we have on the code. And look here, state keys, code to review. We can, instead of doing that, we could be able to define our own key, right? But when you have a very complex system, you may need to have a separate file to store your state keys. So that's exactly what we do here. We have a constant with these state keys, where we create a dictionary with the state key and the string that represents our state key. So we can import through the whole project, right? So after doing that, I will not enter in details of each of those functions sometimes because we don't have time to. But right now we're gonna, let me copy here, module 4, step 3. We're gonna put the way we're gonna run on the thread pool to run our code and not block other tools to being called at the same time. And here, we're gonna paste the function that is gonna extract from our code using AST. Let me see, what is this? Indentation. I think. Did I do something wrong? Nice. So we are gonna build, we are gonna paste our helper function here, and all the complexity on it is gonna be stored on our tools. It is at the end. This is the helper function that is gonna use AST that I have already said to extract the functions from the code. So if you look here, it is going to look to the code and it's going to see if our code is a function, if that piece of code is a function, or if it is a class, or if it is an import, or if it is an import from. This is going to transform our code in a way that LLM can have more information to quickly understand what it is about and quickly answer how many functions, classes, imports, docstrings, or metrics are present on our code, right? So after doing that, we're gonna open our agent that is gonna run this tool. So let's do a quick reshare. We created our states, we created our thread code execution, and we create the function that calls our helper that is gonna take as an input the code itself, remember code as a string, and is gonna return a dictionary about the information of that code. And right now we are gonna create the agent that we're gonna use that tool. So sub-agents, review pipeline, sub-agents, review pipeline, and code analyzer. Yep. You can copy and paste this here. So going from our first example, you can see that right now we have two different things. The first one is tools. This everyone knows, right? This is just the standard tools used for any agentic thing. But we have output key. What this output key means? Does anyone have a guess? Is the response, but what does it mean to the agent itself? This is telling the agent that when you answer the thing, the question, whatever, store this in the state, right? In which key? This one, structure analysis summary. So instead of answering this to the agent that is calling this agent, we are storing the response inside of a key. So we can access what this model exactly has answered in other agent or in other tool without losing anything. Because if I answer this from other agent, I need to trust the other agent, the LLM, to answer this again to another tool or whatever. So if we look into our constants file that I have just showed, we have a key, right? So that's the way we access the result of this model. So after doing that, we can test. And let's see, let me just make sure that I have tests. Yep. We are gonna just test this agent. Okay, this happens. Why? We need, let open again, we need the .e command. Again. Oh, you know what happened? You know what is wrong here? Does anyone have a guess? I'm not on the virtual environment. Now I can run. Let's wait until it responds back. Yeah, look here. Do you see here? Code review, assistant.tools.tool, analyzing code structure, and another info, analysis complete two functions on class. This is coming from our tool, and this is the answer. Do you think the answer is good? It is, right? It has the information that we are expecting. How many functions, how many classes we have, and some observations on it. This is coming from our prompt itself, right? So after testing it, let me see if we have another additional step. We don't. We can pretty much infer that we have used the functions that we want. We have stored it inside the key, and then we can assure that it has worked. And again, this is a troubleshooting step here. If it doesn't work, run pip install -e. Now we are gonna run our pipeline, right? So the first pipeline, code analyzer that we have already done, then style checker, test runner, feedback synthesizer, and then the states that we are, it's too bad, right? The states that we are gonna update through this pipeline. So, let's go. We're gonna open the tools again, and we're gonna search for this one. Let's open the editor, let's open the tools, and let's check for this. We're gonna add this style checker tool that we need. Let me paste it. Nice. I will not enter in details because we don't have time to. Then we're gonna place and paste the helpers functions that we need. So let's paste it. So this top function that we have just added is gonna use this underline calculate style score to give a score for the style of our code. Then after it, we're gonna open our style checker agent. So if you go back to the pipeline image that I've shown, you have the style checker agent. So now we're gonna create the agent to use the tools that we have just created. So we're gonna go here, review pipeline, style checker, and let's put this. This is different. This is the first time we see instruction provider. What is this instruction provider? If you see, we're defining a string here called a template. You have this thing, and you have this instruction underline utils.inject session state. What is this doing? This is replacing this string if we have in our states a key named like that. Okay? So for example, remember that on our agent, on the first agent we built, we saved the result using output schema into a state. And right now, we can get that result back inside of our prompt. So remember that I said that using states against ADK, you can access this through multiple layers inside the tool, and now we are seeing how to use this to improve our prompt. Because you cannot do that here. This is not going to parse the result from the state. So you need to create an instruction utils first, right? Exactly what we did here. So if we have this await instruction.utils.inject session template, you can replace the values. And keep the attention here, context. We're passing the context. From where? From here. Context, read only context. See the difference. adk.agents.read-only-text. And if we go back on the tools, let's go up, you have this google.adk.tools context. So tool context and read-only context points to the same thing, which is the state on our pipeline, right? Just to make sure that this is clear for everyone. Then we're gonna create our agent itself. In my personal opinion, is much better than the older one because we are putting this prompt inside of an external function, so it's more beautiful for me. And again, we're using this output key, right? So we are saving this inside of our model, inside of our state response. Nice. After that, we're gonna create our test runner. And this is very cool because ADK has a way for us to test our code in a sandbox. So this is very nice. Let me paste here. And this is new. The new thing here is code execution, built-in code execution. So if we go up, we can see that we have from Google.adk again, code underline executors, you have built-in code executor. So this is going to allow the agent, and we are instructing this on the prompt itself, to run here. Third point, execute the test using your code executor. So this is going to allow ADK to test your code against his built-in code executor. So this is a very good use, right? So this is just an explanation about the difference between memories and state. Is it clear for everyone what is a state and why this is different from memory? Or not? That no shame if it's not. Is clear for everyone or not? Okay, so for example, states is an information that we only access during the pipeline. You can store the states using some workarounds, but the memory itself lives on the DB or in the memory if you don't connect to a third-party provider. But you can collect information from your past executions. So the pipeline is able to answer you when you input the code. Man, this is the third time that you forget an if. Please study. Or something like that, you know? Like, is it the 101 time that you have been forgetting to put a semicolon at the end of the line? Please put the semicolon, always. So memory allows the agents to personalize the answer based on past executions, right? And based on your personal preferences. So you don't want to Gemini to recommend you something that you already said that you don't like. So this lives in the memory, okay? So ADK has 3 types of memory that we can use. In-memory session service. So when you do Ctrl+C, it ends up the memory. We have the database session provider, which stores the memory on the database. And you have a more cool thing called Vertex AI Memory Bank. What is it? The Vertex AI platform is going to take your interactions with the agent pipeline and is going to extract memories from it. So it's going to look into your pairs of questions and answers, and it's going to see what is a memory, what is important for you. And it's going to store this in a dictionary inside of Google's cloud structure with your preference. So Pedro likes to travel by airplane, for example, because I mentioned this on the conversation. This is very cool. You can build this at your own. There is a lot of startups in San Francisco doing that, but you know, Google has this as a default. So it's a great thing. Yeah, this is just showing us how this is structured. And then let's go back to the tools.py. And we're going to search for this because we're going to create our feedback agent. Right? So we're going to put here our feedback tool. Then we're going to create this updated grading process tool. So this is going to give you a grading for your development. So seeing if you have been more intelligent or not with your code, for example. And this is going to save, the grading report. And then we are going to use this into our new agent called feedback synthesizer. So please, we're going to call the instruction provider here as we do on the other agents. And then we're going to create the synthesizer agent. Okay, and pay attention, output key, final feedback. So it is the final feedback, as it says. And Pedro, okay, you create 3 separate agents. Where we run them together? We're gonna do here. We're gonna open this agent.py, and we're gonna place all the necessary imports that we need here. So what is this doing? Importing all the agents that we have built, right? Into our current Python directory. And then we are going to create the pipeline. And remember the first slide. This is a sequential pipeline, okay? So look here, sequential agent. Why this is important? Let's suppose you create an orchestrator without saying that this is a sequential thing. and you say, please LLM, run this agent, then this, and then this. Who assures you that the LLM will run on that sequence? No one. So we have a coding approach here through Google, which is called sequential agent. This is gonna assure that we are gonna run first the code analyzer, style checker, test runner, and feedback synthesizer in the way we define it here, right? If I put the feedback on the top, it's gonna run it first. So this assures that whenever that agent finishes, it's gonna call the other one. And should be in this way, because remember, we are saving the output into the state, and we use the output from the previous agent to run the second, okay? And this is the root agent. This is a mandatory thing, right? Without an agent named root underlying agent, ADK will not run. So we should name it that way, right? And you see, the sub-agent of this root agent is our pipeline. In the future, we're gonna change this root agent and put two pipelines here. The first one that we just built, and the code fixer pipeline, which is a loop. So after that, we can run this ADK code review assistant. Let's go back and let's run. Look, it has instantiated a URL for me locally. Pedro, how can I open this? Here, web preview. Look at the port, guys. 8080. It is wrong because it is on 80,000, right? So change port, place your port number, change in preview. Hopefully it's gonna work. This is the internet, folks, right? It's not Google. Worked. But look here. Where is my agent? What I'm seeing here, the sub-agents folder. What is the code review folder? We run it wrong. So let's do Ctrl+C. Let's go down one repository, and then now we should see the folder of our agent. Oh, it doesn't exist. Weird. Let's go back again and do our, I think it is our pip installer.p again. Weird. ADK web code review assistant. Worked. Magic. No, valid path. ADK, sorry. This is wrong. ADK code review assistant. Yep, let's go back. Let's see. Code review assistant, finally. So, we're gonna test it. Let me get the answer here. Please analyze the following. And if you look, it is the same thing that I have pasted on the slide. So it is gonna analyze regarding our pipeline, and it's gonna look through that 3-agent sequential thing that we have done, and it's gonna answer us back. So here, this is a new screen for, does anyone here never open ADK web? Raise your hand. Nice, okay. So this is a visual interface where we can infer from our agent what has been working, what has been doing here, what is being running. So if you see, it's different colors. So each color is a different agent on our pipeline. And if you click here, you can see what has been sent to the tool, what the tool has answered you back, what has been working and being done on the states. So you can pretty much understand everything that is happening here, right? So see, for example, it has just passed into the code analyzer agent, and right now it's on the style checker agent, and this will keep running. To speed up, I will go back to the code and keep doing it until we get our answer, right? So we built our first pipeline to code review the code, and right now we are gonna do this loop agent, code fix loop. I will be very fast, it doesn't take so much time. So we're going to create a loop agent. Remember the sequential structure, sequential agentic pipeline? We are now using loop that is going to call our agent X times until we get the answer that we want. And how do we stop the loop? Doing this. Let me see if it is here. It's not, but there is a function called escalate. So whenever we do escalate inside of Google ADK, it's going to stop the loop. So it will prevent our agent to keep executing until the infinite. So yeah, let's go here. I will pass this. Let's go to our code fixer agent. Let's go back to editor. Inside of our fix pipeline, code fixer agent. Let's put our instruction provider here. Let's put our code fixer agent here. Nice. You can pretty much see that we are using this built-in code execution again. So we used it in the first pipeline, and now we are using it again on the second pipeline. And then, as everything, we are using the output key as code fixes we store on the state. And I didn't told this before, but we are storing the model keys, the IDs, the ARMs, the identification for the model, Gemini.5 Pro, or whatever we may use inside of a config file. So this is good when we want to change to the whole pipeline, and we don't need to update each of the agents file that we have on the repository, right? So after doing that, let's go back. Let's go to the fixtestrunner.py and place our instruction provider again. Nice. And let's place our agent here. What this is gonna do? This is gonna test the fix that the agent has built before. Then we're gonna go to tools. We're gonna search for this. And there is only 4 more until we finish the lab of today. And let's see. Oh, look at the report. Summary, strengths, code quality analysis, style compliance, structure, test results, broken. It's broken. So it's good because it tested my code and saw that it's broken. So man, your test is broken, your code is broken. And the recommendations for improvement. This is very good. Very good. So let's keep building. Let's paste this tool. Validate fixed style. So we can assure, let's put here, that we have our style validated. And then let's go down. Let's place this compile fix report. Nice. Let's go back. Oh, remember I said about escalate, so we can exit the loop? It's here. to_context.actions.escalate. Whenever this is true, it will end our loop. So in this agentic pipeline, we have a max of 3 loop executions. If the agent wasn't able to make the thing happen, it will end on the 3rd one. But if it do it the first time, it's gonna end on the first time using this escalate.true. And then we need to save, right, our report at some place. So before doing that, let's add our fix validator agent. So let's go back here, fix pipeline, fix validator, sorry. Yeah. And let's put our instruction provider. Look here, we are pressing information from the states again. And then we're gonna define our agent together with the tools that we have just created, and then final fix report. save it on our state again. So this is explaining how escalate works in a more detailed way. Let's go down, and remember, on our agent.py, the main one on the root, we have defined only our 3 agents for the first pipeline. Now we should import the other ones, right? So we're gonna copy this, and we should paste on our main root agent. This is a standard, right? We should have this agent.py defined on our root, and then the other agents inside the sub-agents page. So we are gonna place this new import. Let me place this here, right? So, important thing, you see agent, sequential agent, and loop agent from adk.agents. So it is ways that we can use code structures like run, if, while, and sequential things inside ADK, right? So, create fixed loop. We are going to orchestrate our fixed loop. Let's put this here. And then we have the loop agent and the sequential agent. Okay, so we have 2 things running inside of our agents that we have on the code review, on the code fixer pipeline. And we are going to remove this root agent from here, because this root agent only considers the first pipeline. So we remove that, and we are going to place a new root agent. So attention, code review pipeline, code fix pipeline. Let's go to the code fix. Code fix pipeline, fix attempt loop, which is this one. See, so this is gonna run at least 3 times until the escalate is sent. When this is sent, the sequential agent is gonna call the fix synthesizer agent directly as a sequential thing, right? So let me just make sure that we have not lose any kind of thing here. So yeah, go to the thing synthesizer and let's place our instruction provider here. Ooh, we are almost finishing. And then our fix synthesizer agent. This is gonna store our report, which we can call artifact. And then we go back to the tools and place the last function of today's lab, sadly, which is this, and we place it here. Nice. Perfect. So now we have built everything from our lab, and this is the end of the lab. So let's stop and let's run it again, so we can make sure that we have all the things working, both pipelines, and that we can see the results on both pipelines. So I will do Command R. See, cannot find specific session. Why it not found this specific session? Does anyone have a guess? Because we defined it on our session memory service to be in-memory session service. So when I stop, I don't have a record, but I can use using the Vertex AI memory bank, or we can use like database session service to store this. So it is working, and let's test our agent again. And this is gonna take a little bit of time. So while it runs, I will ask if anyone has a question that I can answer. Yeah. If you don't feel comfortable speaking English, I can translate for me.
Well, yeah, I can ask.
Okay.
So I noticed you're using like one model for all your agents, right? But what if I want to use a different model for a different installation? Like for example, I want a security reviewers,
Mm-hmm.
Okay, there's a specific model for that. So how would I do that?
Okay.
Right.
Yeah. Going back to our code, whenever we define an agent, we define the model, right? What I am doing here, let me go to the config file. Let me just search, because it is a lot of things. Worker model. I am using this Gemini.5 Flash, but you can use whatever model you want. This is too, it is too much over engineering, but it is the standard. You can just go here and place Gemini 2.5, whatever model you should use, right? You may want to use. So this is just the way we define these two different agents. You can have like a security review model or a more stronger model and use these in different review agents. Right? Nice. You're welcome. Anyone? Let's check our result. Oh, this can happen, okay? But this is an issue for Google's, not for me. This happens sometimes, okay? This is a thing that can happen through every lab. So this 429 error. This is a thing that we as GDE are. Let me stop. Yeah, let's see. This 429 is a thing that Google team is handling right now. So hopefully in some days in the future they're gonna fix it. So more questions? Yep. Okay.
But we have that. I mean, we are doing the same. It's one response right, right? But in a production scenario, how to measure that those changes are giving that expected response to those users?
Okay. For example, is the response a JSON file or can be anything, right? So if it is not a parsable thing, we can use something called model armor from Google. This is like another LLM step. You can do it your own. You don't need to use model armor, but what this essentially do is it picks what the agent has answered back, gives you another LLM, a fast model usually, and then against your rules, it sees if it passes or not. If it doesn't pass the rules, it's going to go back to LLM with the result of the test, and the LLM will improve that answer in a way that passes what you expect. For example, if the LLM is asking about code, only answer code-related questions. So you can check this using an additional step. And if you were parsing JSON or expecting a structured output, you can use output schema, if I'm not wrong, to check to create an identical model and pass to ADK that is going to assure that the ADK is going to answer that valid JSON. So you don't need to beg the LLM, like, please, for God's sake, answer in this JSON that I am asking you. So you can use code structures to build it. Is it answered?
Yes, aside from that, how can we get the accuracy of that in an enterprise structure? We need to justify this agent is right. I mean, we are under 95 or above to 95, right? So this tool is helpful to get this accuracy metric.
It is just, you're gonna need to do evals. You need to test the agent, do evals automatically or not, and see if the answer is good or not. If it's not, you can either fix with prompt engineering, or you can either fix doing a LoRa inside of a language model that is open. For example, Gemma 4, which is very good.
Oh, okay, last one. So this eval needs to be reviewed by a human, or we can use a human as a judge. I mean, AI as a judge.
You can use. I will give an example where we have both. For example, going back to that IBM thing that I've told you on the beginning of the talk, we are looking to programmer's code and seeing if that programmer, if that developer has the skills that we expect you to have based on your role. Sometimes the agent gives you a score that doesn't relate to your work or who you are. So we have like a standard average value of the score that we expect, and if the LLM gives you a score that is or too high or too low from the medium that we have set it up with the managers, we're gonna give this to a human to check. So it will check your code, the things you are expected, and it's gonna say like, is good or is not. Like, the LLM is correct or not. So this is human in the loop. Also, we have another step which takes all of those inputs against another LLM, a pro model, like with the provider that you may want, and check if it is correct or not, the answer, based on the rules that we have written to them. Basically, it's test and see what suits better for the case.
Just to put it that threshold in a correct way for the business, right?
Yeah.
Okay,
Exactly.
thank you.
You're welcome. Guys, so just another thing. This can happen also, right? This is another expected thing. So I will try one more time, and if in this third time we have some kind of things that I've just showed you, we're gonna end it up here. But all the pipeline has worked, and I will go through all the agent things on the log, and I will show again, right? So, more questions? No? Okay, while it's running, I will put my social network here. So if you guys want to connect with me on LinkedIn, on Instagram, or whatever, you can be free to do it.